Hello everyone, my name is Ozgur Ege Aydogan. I am a neuroengineering graduate research assistant at Osaka University's Graduate School of Medicine, Department of Neurosurgery, where I work on the applications of brain-machine interfaces, which focus on real-time robotic arm control using EEG signal. I'm currently work on developing BMI systems and optimizing neural decoding pipelines. I was a student in Neuromatch deep learning and computational neuroscience courses in 2021 and 22. And after that, I became a Neuromatch deep learning teaching assistant in 2023. Um, in those courses, I led teams working on ECOG-based motor imagery classification and representational mapping with DCNNs. I am passionate about making deep learning more interpretable and accessible in neuroscience. I am also excited to support these deep learning students on this journey in the course. So when we look at our topic, PyTorch's autograph system, which is central to training deep learning models, we can define autograph as PyTorch's automatic differentiation engine. It builds a computational graph on the fly as we perform tensor operations, which means it tracks all operations on tensors. So each operation creates a node in the graph, and the connections represents the flow of computation. But why is this important? Because we want to update model parameters using gradient descent. We need the gradients of the loss with respect to each parameter. Autograph allows us to do this efficiently using reverse mode differentiation, which is commonly referred as backpropagation. So, and therefore, we can just call backward function on the final scalar loss, and PyTorch takes care of the computing all the gradients in the background. So let's examine the exercise 2.1, which demonstrates the building a simple differentiable model in PyTorch. So we start by defining our model class, and we initialize the weight as W and bias B as tensors which requires grad true. And so the PyTorch can compute gradients doing backpropagation. So next, the forward pass function. It defines the forward pass, and they ask us the prediction. So the answer is torch hyperbolic tangent x times seth w plus seth b. The reason is this represents a simple single layer neuron. It takes an input x, applies a linear transformation, which is x times w plus b, and passes the result through a nonlinear tangent H activation. This allows the neuron to model complex nonlinear patterns in the data. Then we define the loss function, and it asks us the loss. So what is loss? Loss is square of y2 minus y prediction. Why? This computes the squared error. This is a standard loss for regression tasks, and it measures how far of our prediction is far from the true label. And finally, we test everything, and this will output the prediction and squared loss for our input. So thanks to autograph, we could now call x and square loss backward function to get the gradients from W and B. Thank you for listening.